sign-up sheet, the consent sheet. Yeah, volcanism. Are there any questions before we get started on that? Volcanism. We're looking at the association of volcanism and plutonism, the occurrence of molten rock and molten rock activity with plate tectonics. And where can we get melting? We can get melting at divergent boundaries from a drop in pressure as the plates separate. We can have melting occurring at convergent boundaries where there is subduction, and one plate is being forced back down into the mantle where it's hot, and it's going to melt and come back up. And we have melting occurring underneath continents at continental hotspots from the heat coming up from below, melting its way to the surface, and also at oceanic hotspots. So let's see, we had divergent boundaries, convergent boundaries, and hotspots. What boundaries left that we didn't talk about yet? Transform. Transform plate boundary, plates move past each other. Are we going to get any melting? No, we won't. We'll get a lot of friction and frictional heat, but it's not going to be enough heat to cause melting to where we can get igneous activity. So transform boundaries, we're not going to see plutonism, we're not going to see volcanism. There's no molten rock. Okay. Let's look at some. Volcanic hazards. Alright, plastics down here, ash, gases. Wow, ooh, my favorite. Hydro, blast, cars. Good grief, I think that's enough. Now, the biggest problem with volcanism is that stuff comes out of the earth and it could be deadly. Some of the most common things that are going to be the result of volcanic activity are pyroclastics, gases, lava, pyroclastic flows, and lahars. Lahar is Polynesian for mud flow. And the reason why we call it a lahar and not mud flow is because mud flows can form by other processes, like heavy rainfall on steep slopes. So by calling it a lahar, then you know that specifically this is a mud flow that was caused when a volcano erupted. Now, pretty much, if we're going to have a mud flow, we need mud. How do you make mud? Water and dirt, right? Well, when the volcano erupts, you're going to have plenty of dirt. You're going to have all of the soil and whatever was already on the mountainside. Plus, you're going to blow to smithereens much of the top of the mountain into dust, into dirt, and the powder. Plus, you have the ash, which is mostly tiny, super cool droplets of lava. So you have plenty of clay and dust and ash and dirt to make the mud with. Where's the water coming from? Some may come from the steam. Most of that's going to go up into the atmosphere. Mount Kilimanjaro on the equator in Central Africa is over 21,000 feet tall in elevation. What's at the top of it? Snow. What's going to happen to that when it blows up? It's going to melt. That's where your water is coming from. Yeah. Most of your composite volcanoes, they're tall enough, typically well over 10,000 feet in height. They're tall enough where they're covered in snow year-round. And many of them will have a substantially thick snowpack that can be easily several hundreds of feet thick. So when that eruption occurs, that stuff's melting. And you'll get not only massive mud flows, but you may also get catastrophic flooding. For example, in Iceland, that's one of their primary volcanic hazards is flooding. because they're on the island of Iceland. They're covered in glacial ice on much of the island, and many of these glaciers actually are on top of the volcanoes. So the volcano erupts underneath the glacier. They get catastrophic melting, where you can get literally hundreds of trillions of gallons of meltwater like over a weekend. And it all goes rushing on its way towards the ocean. So they get catastrophic flooding. So lahars, mud flow, cause. Now the nice thing about mud flows is that they are going to follow pre-existing channels. They'll follow the stream and river valleys that flow down the sides of the mountain. So as scientists, we got a pretty good idea ahead of time where that's going to go. So in an eruption, we can put out proper warnings and advisories and evacuations to target areas that may be close to where these mud flows are going to go. So we can get people out of the way ahead of time. Now that's if they listen to us. In mid-1980s in Colombia, in South America, there was an eruption of Nevado del Ruiz. It's a massive stratovolcano. And scientists had warned the government and local officials that the eruption was imminent and that they needed to evacuate communities, especially ones in the higher elevations near the mountaintop. And they delayed those evacuation orders. And they were urged several times, we've got to get these people out of here. We need to move at least 10,000 people out of harm's way. Well, by the time the eruption occurred, it was too late for people to leave. They were not evacuated in time, and that volcano is famous for producing devastating mud flows. And there were huge mud flows that came down off the mountain, and huge landslides, and well over 15,000 people were killed. If they had listened and started evacuating people when they were suggested to evacuate people, casualties may well have been only in the hundreds. We try, but we're not always listened to. But it happens. You've got to know where that's going. Mud flows can travel at speeds of 45, 60, 70 miles an hour. They'll have the consistency of wet cement. So you get hit with wet cement at 60 miles an hour, you're not going to live long after that. And they tend to be hot. They tend to be quite hot, in some cases close to the boiling temperature of water. Question?
Do you have any idea how long it'll be until they have the next eruption?
Where?
Like, with any volcano?
With any volcano? Ones that we know are active, meaning they've erupted in the last 10,000 years or more recently, they're under constant surveillance. They're monitored 24/7. In our country alone, we have 5 active volcano observatories. We monitor the volcanoes of the Cascades through Washington State, Oregon, Northern California. That includes Mount St. Helens. We have one in Hawaii. The Hawaiian Observatory that monitors Hawaiian volcanoes. There's one in Southern California, Nevada region that's monitoring the Long Valley caldera, monitoring that activity. Of course, there's definitely one in Yellowstone National Park, watching that thing 24/7. And there's also a volcano observatory in outside of Fairbanks. In Alaska, that's the Alaskan Observatory that's watching those volcanoes.
When was the last time one erupted?
There have been some minor eruptions of Mount St. Helens and Mount Rainier in the last decade. There have been some indications of eruptions in the Yellowstone area since the late 1980s. And there have been minor to moderate eruptions throughout the Aleutian Islands off Alaska since about the early 90s. The last major eruption would have been Mount St. Helens in May of 1980. Yes?
What did you hear about the earthquake they just had actually? Did you hear that? They just had an 8.3.
Oh, recently?
Yeah.
No, I didn't hear about that. Really? Wow.
I think only 5 died.
Well, I mean,
That's pretty good. That's big, pretty big.
Wow, no, I'll have to look that up after class.
It's 6,000 miles away.
Yeah, easily. Was it offshore?
Yeah, it's offshore.
Offshore?
33 miles away from whatever that closest city is.
Wow.
It's a
That, they say anything about tsunami?
Yeah, they
Yeah.
south,
Definitely.
away is Hawaii.
Oh, yeah, sure. 1964 Good Friday quake in Anchorage, Alaska, my personal favorite, sent a tsunami to Hawaii that killed well over a dozen people in Hilo.
And that's your favorite.
That's my favorite. My favorite quake. Yeah, I mean, people, of course, now, it was the 1960s, what can I say? People went down to the beach to see the tsunami come in. That's like going to the river to watch a flood. Which people did here in Dayton in 1913. When they were, oh my gosh, the river's all the way to the levee. Really? Let's go look. And yeah, and they were there when it broke. And they were, how many people were out there? It's along the lines of, oh, this is gross, smell it. Oh, okay. So it's just a human nature. But no, I'll have to look that up for sure. Yeah. Yeah, Chile is on a subduction zone. There's a plate called the Nazca plate, an oceanic plate that's moving eastward underneath western South America. And that's, if you get some powerful earthquakes. Let's see, what else we got? Pyroclastics. Plastic means broken. Plastic. It's in reference to broken pieces. Broken pieces. Pyro means fire. So pyroclastic is fire pieces, fire bits. And basically it's going to be solid material that's thrown out of the volcano. One of the most common of the pyroclastics is ash. Ash is a combination of powdered rock and glass. Now the glass is from tiny microscopic droplets of lava that get sprayed into the atmosphere like a mist. And of course, being such tiny droplets, they cool and solidify instantly. And they form these little tiny shards and strands and little tiny microscopic pellets of ash, glass. That and powdered rock. You gotta think about that for a minute. Powdered rock. You know, if I grab this thing and I go here, bring this rock home this weekend and powder it. You leave school today, where's your first stop? Menards for a sledgehammer, right? You're going to be busy. Right? The volcanic eruption from a highly explosive composite volcano, those gases build that pressure, and you can easily lose over 1,000 feet of height off the top of the mountain when that blows. It goes into ash, into dust. It can be that powerful in eruptions. Because it's so fine and tiny, that ash can easily be picked up by upper atmospheric winds and circulated globally. It can take months to years for ash to completely settle out of the atmosphere and return to fall out to the ground. Ash is a reflector. It prevents sunlight and prevents heat from reaching the Earth's surface. If you have substantial ash in the atmosphere, you will impact global climate. You will have definitely changes in regional temperatures and regional sunlight and regional rainfall. That has a direct impact on agriculture. When Yellowstone National Park erupts, we will get ash here in Ohio, all the way from Wyoming, maybe an inch or so. Timing is going to be critical. It'd be nice if it blows up in winter. Because in wintertime, there won't be 8 states of cropland covered in ash. Those crops will be harvested by then. If it falls in the middle of summer, we're screwed. Because that ash falling on Nebraska, Kansas, Missouri, Iowa, through the corn belt, the wheat belt, the alfalfa belt, at the height of the growing season, that ash will bury those crops and destroy them. Ash in the atmosphere will block sunlight, and what plants remain will die because of lack of enough sunlight to keep going. You can't breathe ash, not for very long. Your lungs don't work well on powdered glass and rock.
So it's just the ash falling on the inside.
Definitely get inside and get a mask, get a respirator.
That'd be like if you went and you set your head in like a fireplace, right?
Yeah.
And like fire.
Well, the ash is mostly just the particulates. You inhale that and it'll literally just clog all your breathing structures and then you just suffocate.
That, I looked up that video that you were talking
yeah.
about, and is that what it was? Because
Yeah.
it got into the engine and started, just like sandpaper.
Smoke.
It was really, and all the paint.
All the paint was gone, and the windows were all scratched up. Yeah, it's
Yeah.
from the ash. It's powdered rock. The whole place got sandblasted.
Yeah.
Flying through there at 400, 500 miles an hour. Yeah. That'd be a flying guy to get on it. Oh, wow, cool! And then I turn around and shoot. But, ash is awful. Living things aren't the only things that breathe. Machines breathe. If you're going to run anything in a combustion engine, whether it's a car, a train, a boat, a plane, you need air. You can't breathe that stuff. Airplanes, it is exceptionally dangerous for airplanes to fly through ash clouds. Now, those big jet engines on those airplanes run at very high temperature, and they rely on the air coming in not only for combustion, but to help keep them at proper temperature so they don't overheat. Glass melts at low temperature. Doesn't take much to melt glass. And that stuff getting sucked into those jet engines, that ash in that engine will melt and go to molten rocks. And then that gums up all the fan blades and the turbines and the moving parts of the engine, and the engine stops. And now your plane at 30,000 feet becomes a rock. Not good for airplane. 1980s, there was a major eruption on a little island off Alaska called Mount Redoubt. Up here. Mount Redoubt. And a small plane flew through the ash cloud unknowingly. Engines cut out, lost power. The pilots put the plane into a nosedive to try to cool the engines and be able to chip that material out. And they were able to get a restart within about a mile from the ground. That's only about 5,000 feet from the ground, which sounds like a lot, but it's not. I mean, and they were able to get at least one engine going again, and they landed safely at Anchorage. It is dangerous. We have a lot of ash-producing volcanoes around the Pacific Ocean. We also have a tremendous amount of commercial airliners, both with passengers and cargo, back and forth across the Pacific every day. So trying to come up with technologies to detect these volcanic ash clouds so that planes can be diverted away is definitely at the top of the list. There are some technologies out there, but they need improvement. That's why back a couple years ago, when that ginormous, I can't pronounce it either, volcano in Iceland was erupting, and people in Europe were really upset and ticked off because all of their flights were canceled for like a week. Yeah, they couldn't risk those planes flying through those ash clouds. Or we have a downed airliner in the North Atlantic. I know it's an inconvenience, but it's either that or you learn how to swim real fast. Ash does not show up on radar. Radar picks out the water droplets in clouds, picks up that density difference of the water droplets. Ash is powdered rock, it's dry. Visually, it looks just like a regular cloud. It's 30,000 feet, you don't see the volcano it's coming out of, you just see this cloud. Very dangerous. How do you make cement? Anyone here ever make their own cement, their own mortar mix? You basically get a bag of powdered rock, you mix it with water and put it where you want it and let it dry. Right? Basically, right? When this ash lands on rooftops and it gets wet, it becomes cement and can lead to the collapse of rooftops and structures and buildings. Oftentimes, after significant ash fall, you'll see people up on their roofs with snow shovels and brooms getting the ash off the rooftop because it will lead to roof collapse. You can get that heavy. Awful stuff. I should have brought some. I'll have to bring some next Tuesday. Awesome stuff. It's incredible. It is, however, excellent for soils because a large component of that ash is powdered rock. What's in your vitamin pill? What's in your Centrum? What's in your Flintstones? Powdered rock, powdered minerals. When ash settles onto the ground, it's like a one-a-day with iron for all the plants. It's a vitamin supplement. That's why so many people live so close to volcanoes. It's not for the skiing. It's not for the beautiful scenery. It's for the agriculture. Anyone here ever been to Hawaii? My sister and her husband, they go there like once a year. Us guys. I'll probably never go to Hawaii because I don't do planes. But I do a boat meeting. But they said in Hawaii, they grow this special kind of pineapple. And it's a pineapple that's only sold in Hawaii. They don't export it. I just said, oh my gosh, it's the best pineapple in the world. I've never had pineapple this good. It's really, thanks. And you're telling us about it, knowing that we can't get it unless we all go to Hawaii. But the reason why is because of the volcanic ash. That just enriches the soil so much. It's good stuff.
You're not allowed to bring it back to the state?
No. They won't let you bring it out of the state. No. They're pineapple. They're fish. No. They won't let you take it. No.
So basically when it erupts, we're all going to be screwed for a year or two, and then we're going to have really
Yeah. Oh, yeah. Yeah. We'll be really cold and really hungry for a few years, but once the ash gets out of the atmosphere, you get more sunlight, and you reestablish better rainfall patterns. We'll be eating like meat. Those of us that survive. Yeah.
Can you imagine the panic? I mean, when we get a dusting of snow, everyone runs.
Freaks out, yeah.
Yeah, they clear out the grocery store.
Yeah, you can imagine. Yeah. Gotta get your toilet paper and eggs before that. Now, other types of pyroclasts include bigger items. This is called a volcanic bomb. This was a spattering of lava, just of lava that got shot out of the volcano, and it's cooling and hardening as it falls to the ground, and it makes these, weird shapes. It's whatever shape that blob of molten stuff was when it got spat out of the volcano. That's called a bomb. There's another bomb. The ease with which this rolls is very deceptive. It's like, oh my gosh. This is a bomb also. Notice its lovely teardrop shape because it's falling through the atmosphere as semi-liquid, cooling and hardening on the way down. These blobs of lava can be shot 10, 15, 20,000 feet up out of the volcano during the eruption. What goes up
must come down.
My Alan Parsons fans in here, what goes up must come down, right? Now, this thing comes down, it can fall several miles from the volcano. It can be bigger than this. It could be the size of a small automobile falling. They've been known to whistle as they fall, like German World War II rockets as they fall. When they hit the ground, if this hits the roof of a 3-story building, falling from 10,000 feet, it's going from the 3rd floor roof to the basement. And it's just recently formed rock. It's still going to be very hot. So after making a hole all the way through the house to the basement, the house is going to go woof and probably be on fire as well. People get killed by bombs being blown out of the volcano. If you're several miles away and you're taking pictures and you see a big shadow showing up underneath somebody, you run the other way. That means something's coming. Now this one, if you look carefully, you guys can probably see, but every now and then there are these red marks on here. And that's because a friend of mine and I, we went to the rock yard and bought this thing. It's a long story. And put it in the back of my red pickup truck. And didn't really realize just how round it is until we hit the first stoplight. Stop, bam! And then take off, and bam, into the tailgate, and bam, into the front. Yeah. So it's got all these little red skate marks on it where it hit my truck, rolling around on the way back to the flare. That's a bomb. And if anyone wants to try picking this thing up just to get an idea of the weight, be careful, don't give yourself a hernia, but it'll give you a pretty good idea. This, imagine that falling from 12,000 feet up. It's going to cause some damage. This particular bomb is out of Idaho. Man, I think I had my weed. So that's another thing that can come out of a volcano.
Do you went all the way to Idaho to get that?
Oh, no. We went to, of course, they're out of business now, but we went to the Gregory Stone Company on Gettysburg.
They went all the way to Idaho to get that?
Oh, no, someone else did. No, we went to the Gregory Stone Company. Used to bring in all kinds of rocks for, like, landscaping and pavers and countertops and stuff, so we got a lot of rocks from there. And we went there one day, and this was sitting there, just sitting on top of a big pile of other rocks, volcanic rocks, for like gardens and landscaping. They were just sitting there. Like, and my friend and I pulled in, and we both say, "Oh, it's a bomb!" And the guy was with us, and I was like, "What? Oh my God!" And so we had to explain to him, and he's like, he didn't charge us for it because just say, "You sure? Oh, good. Take it. Get the hell out of here." So he let us have it. But
That way you're not supposed to say the word bomb in public.
probably not. But this was pre 9/11, so pretty wild. But so that's just again the power of those compressed gases under pressure. They can blow that stuff for miles. Now gases coming out of a volcano can be deadly. Carbon dioxide, carbon monoxide, sulfur dioxide, hydrogen sulfide, they'll all kill you. Hydrogen sulfide smells like rotten eggs. And you get a good whiff of that stuff. It turns to sulfuric acid in your lungs. Your lungs dissolve and you drown in your own blood. Yeah, just how I want to go, right? But fortunately, in most eruptions, the gases vent straight up into the atmosphere. So they're only mostly a problem for people that are really, really close to the eruption. And if you're going to be that close to the eruption, one of these other things is probably going to kill you before the gases do. Like, they can be very deadly. Lava is the least of those. It's slow. Remember, it's hot, but it's cooling. The farther away it gets from that opening, the slower it's moving. And again, if you're going to be so close to the volcano that the lava is moving really fast, one of these other things is going to kill you first, if you're that close. Lava can, it moves typically 3 to 5 miles per hour. You can walk away from that. And again, the farther away it gets from the source, the slower it is because it's cooling and hardening along the way. Lava is usually more a threat to property than to people. Things that can't get up and move on their own. Now, back in the late 90s in the Congo, that was Nyiragongo that erupted, and it sent some lava flow pretty much through the airport and down the main street of town. And some people were killed because they went back into the evacuated town to steal gasoline. Okay, if you're desperate enough to steal gasoline, that's one thing. But try not to do it when there's lava flowing down the street outside. And they blew up. So God probably not. But otherwise, lava is usually not a big issue. The lava is flowing. The liquid flows. So again, as scientists, we study the volcano. We can tell where the lava is going to go before it comes out. So you get a good idea of where to put up warnings and evacuations to keep people out of harm's way for when it flows out of there. That's usually not a problem. Then there's my favorite, pyroclastic flow. Pyroclastic flow. So it's flow, it's moving. And pyroclastic, again, your fire bits, ash and particles that come out of the volcano. This thing's awesome. Oh my gosh, it's so cool. The volcano. And whoosh, got an eruption. That stuff is just shooting up out of there. Whoosh. That can be jetting out of the top of that volcano. Again, the elevation's well over 20,000, 30,000 feet. That's why it's a problem for aircraft, and that's usually up in the ground where they're flying. And it's all being propelled up there by that gas pressure. Just like when you use a spray paint can or a can of Cheese Whiz or Silly String. You know, that stuff keeps coming out of there as long as there's gas pressure. But how do you know that spray paint can is empty? How do you know the Cheese Whiz is empty? That you'll just, right? You run out of gas. You run out of propellant. What's going to happen to all that stuff that's being blown out when the gas runs out? It's going to come back down because there's no more push it up. There's no pressure to keep it out there. There's no pressure. There's no pressure to keep it going up. It's going to come back down. It's what they call gravity. It's going to come back down. It's going to collapse. We call that the collapse of an ash column. This whole thing collapses and falls back to the ground and goes roaring down the sides of the mountain. That's a pyroclastic flow. They're mostly made of ash and gas. The gas tends to have a higher density than the surrounding air. It will tend to be at the bottom. That makes this mass almost frictionless. That gas will act as a cushion. Coming down the sides of the mountain with little to no friction to slow it down, these things are booking. They could be going over 100 miles an hour down those mountainsides. And they're mostly ash and gas. Where was that gas? That gas was deep underground in the magma. That gas can be at temperatures well over 1,000 degrees Fahrenheit. You get hit with that, you're not going to live. Not long. Pompeii, they dig out the people out of the ash. A lot of them are like this. That's called the boxer's stance. It's a reflex, biologic reflex to extreme heat. They were taken out by these pyroclastic flows. People in Herculaneum down the street from Pompeii at the waterfront, they're found in the warehouses where their skulls are all, bones are all blackened, and many of them, their skulls are cracked and have holes in their skulls. You want to know how that happened? You don't, but you know you do, right? At those temperatures, they got hit with pyroclastic flow. Even though it was more than 5 miles from the volcano, that's how far these things can travel. They got hit with the pyroclastic flow. At those temperatures, your brain boils in your skull, and the steam pressure pops your skull open. That's why their skulls are burst open at Herculaneum. Sign me up for that one. Gone. Wipe out. Early 1900s, 1902, I believe it was, eruption of Mount Pelée. And that's in the Caribbean on Martinique. That erupted. Huge pyroclastic flows came through town, killed everybody. Killed over 10,000 people, burnt to a crisp, except for 2 people survived. One guy was in prison. He was in a concrete prison with only one window that faced away from the volcano. He lived. They found him a few days later. He was badly burned, but he survived. And I don't remember where they found the other person that they survived that died shortly after. That's pyroclastic flow.
I guess it was like he wasn't big enough.
Well, lucky and unlucky. If that were me, with my luck, yeah, I'd survive that. And they'd be like, oh yeah, great, so you survived for your hanging. It's still next week. Yeah. I make a better door in the window. Yeah, I mean, you could. Some time ago, if you guys had like Discovery Channel, for a long time, one of their promos, they had this like, there was a road with a fire truck on it, and there's this guy like in a white suit, and he's running like as fast as he can, and behind him there's like this green hillside with this gray cloud coming down the hillside. They had it on Discovery Channel for years, and he's just running like, oh my God! He's running from a pyroclastic flow. That was in Mount London in Japan, renowned for producing these things. And I don't think it was that group, but a previous group, they were able to get back into the fire truck, but the pyroclastic flow hit them, and it basically burnt the fire truck to a crisp. And they were burned all the glass, melted all the glass out of the fire truck, and they were badly burned, even sitting in the fire truck in their fireman suits. So I think it's pretty toasty. Pretty toasty.
Will we have warnings before the other things up?
Yes. We hope so.
We hope so.
Most volcanoes give us some heads up.
Are we talking like a day, or are we talking like, oh, by the way, sometime this year you might want to start stocking up on some canned food?
Well, year probably be too far out.
Okay.
We're hoping for 3 to 4 days. And we're hoping to be able to say, well, we're expecting a major eruption in 4 days. Now, we're hoping, having said something like that, that it will be 4 or 5 days after that. It may surprise us and be earlier. So, we're hoping for at least a few days, because we'll need to evacuate about 9 states.
So that's something that we here in Ohio will definitely hear about.
Yes, and we'll be far enough away that we won't experience any really direct effects. Things looking a little better. Yeah, we'll be hungry. I won't. I know where to find food. I have a gas room, and don't come by my house after the apocalypse, because meat's as far as I'm concerned. Oh, these ribs are really good. Yeah, they're my neighbors. My neighbor gave you ribs? No, they're my neighbor's ribs. Oh, don't tempt me with the neighbor's dog. That thing is up at 2 o'clock every morning. Yeah, I'm going to eat that thing anyway. So, but yeah, I mean, it's awesome. Yellowstone has an interesting geologic history. There have been times in the geologic past where it's erupted all at once, very catastrophically, and other times where it's erupted in stages. Still bad, but not as bad as it could be. We're hoping when it goes again, it'll be in stages, not all at once. There is magma accumulating within a mile of the surface underneath parts of Yellowstone. There are changes in geyser activity, changes in gas emission. So we know it's accumulating new magma again. So we don't know. We're watching it.
But that could be anywhere from next year to be erupting more in
100. Yeah. So we're watching it constantly. Question?
When it comes to like them being in stages, like how far apart or like on average are the stages?
In the geologic record, potentially weeks to months apart, maybe more.
what are the stages?
Well, it's just instead of the whole park blowing as one part, once, all at once, like this little area would blow, and then that little area would go, and this little part would go. It'll be a multi-phase eruption rather than one.
And we prefer a couple pops for the entire.
Like, I think that's what you're gonna do.
Yeah, there you go. There you go. Yeah. Run! We can predict some volcanic behavior. Again, some volcanoes, earthquakes are a primary look. As that molten rock is rising towards the surface, it's causing a lot of ground shaking. It's got rocks, it's got to move out of the way, it's got gas that's bubbling through and moving rocks and shifting things because of the gas pressure. So typically, in most volcanic areas, you'll start seeing first a lot of increased earthquakes. And those earthquakes will get more and more frequent and more strong in the areas around the volcano. And what you're looking for is that ramp up in earthquake activity to suddenly and immediately just stop. And that's your clue that the eruption is coming soon. Because if the earthquake stops, that means everything's got a free shot. There's nothing that has to be moved out of the way anymore. The pathway is clear for that material to come up to the surface, so that you know that something's coming. Gases also are a good tip-off. Steam usually comes out first, followed by carbon dioxide, followed by sulfur dioxide. So we watch and monitor the type of steam and the type of gases and the quantity, and that's usually another good tip-off that it's getting ready to erupt. But you know, they are forces of nature. They can and do still surprise us. Back in the mid-90s, there was an eruption of Mount Unzen in Japan. It had entered a quiet phase. And so a bunch of scientists and photographers and journalists went up to the mountain, went up to the crater
That's a great idea.
to look at it, take measurements, and take pictures. And while they were up there, it exploded and produced a pyrotoxic flow until when was that? Early to mid-90s. It was like 60-some people. So among them, a world-famous photography couple that were best known for their photographs of volcanoes. They got a good shot.
So are the earthquakes the way that people can tell, or that scientists can tell if it's going to be the stages of it? Like,
For Yellowstone, they're looking at.
it's like in general, I mean, like there's going to be an earthquake, then there's an eruption, but there's more earthquakes after that.
They're usually, after the eruption started, you usually don't get a lot of earthquakes like you did before the eruption started. Those earthquakes usually die down and become much less frequent once the eruption begins. Because the earthquakes are basically suggesting that there's stuff on the move up. And once that's got a free shot and there's nothing in the way anymore, your earthquake stops. Different stages of eruption, they're monitoring mostly gas emission and gas pressure. That gives them an idea of how much material may still be at depth on its way up. Yeah. It takes a while to empty all that stuff out of the volcano. So a volcano can actively erupt for days or weeks or months until it runs out of its supply of gas and magma deeper down. Or until it cools and hardens and floods it up. Any questions? We need a volcano at Maine, Missouri. It's great for downtown tourism. Well, I don't know. It wouldn't be too bad. Maybe a shield volcano. Yeah, all the ash would collect here. We don't have enough breathing problems. Well, volcanism and plutonism produce rocks. They form igneous rocks. These solid rocks do not last forever. Like any rock, over time, they experience wear and tear. They get broken down. They get exposed to sunlight, to heat and cold and wet and dry. And over time, those forces will break down those rocks into smaller pieces. And in some cases, even dissolve them away. Now, with the rock cycle, though, nature will take those little pieces and dissolved material and move them somewhere else and make sedimentary rock with it. So nothing goes to waste, it just goes around, goes around, goes around. But, you know, volcanism, I mean, that'll build a volcano that can be 2,200 feet, so 22,000 feet tall. But over time, it'll wear down to nothing. What's that called? The Devil's Tower in Wyoming. That's basically just the inside core of a volcano. That's the solidified lava inside the volcano. All of the sides have been completely washed away over time. So nothing lasts forever. It all gets broken down. And the processes that are breaking this rock down are called weathering and erosion. That's where I'd like to go next. Any questions?
I got one.
Yes.
So Devil's Tower is no longer.
Oh no,
No.
it's been dead for at least 60 million years. It's lost its heat source, so there's no more magma generation at depth. It's just a cool thing to look at now for aliens to land. Any other questions?
How do they come up with names for volcanoes?
How they come up with names? Same way they come up with names for any geologic structure or geographic feature like a river or a valley. We try to pick names that we know will last for a long time. So it's either named after famous people, or if there are local cultures that already have a name for it, and it's special to them in their culture, like the name of a deity or a previous king or ruler or something like that. We try to keep those names because they tend to be long-term place names that will last for a long time. Yeah.
And those names are applied to Navy observer ships.
Yeah.
Navy observer ships, Gilliland, Shasta.
Yeah.
They're all named after this type of stuff.
Yeah. Well, in World War II, they all like names of states. They had the
Still over some things.
still going.
And
Yeah.
some things were people. The frigates are people. The states where they're all split up.
Yeah. They try to pick names that will just have long-term meaning. Does that answer your question? Any other questions? Let's look at some weathering and erosion. We start with weathering. Weathering is the physical, and chemical breakdown of rocks and minerals into smaller solid pieces and solve I'm just going to put this on a chain around some waste or something. Okay. So weathering, the physical and chemical breakdown of rocks and minerals into smaller solid pieces and into dissolved material. Now these smaller pieces, how small is small? Smaller than what it was. Okay. Smaller pieces can be the size of dust particles, sand, pebbles, gravel, pieces of rock the size of this room, the size of this building, as long as it's a piece smaller than the whole. Comes in a wide range of pieces. And dissolved materials. These are going to be elements and minerals that are dissolved in water. Physical weathering solid pieces, solid sediment. This is clay, sand, silt, gravel, pebbles, boulders, cobbles, chunks, bits, ash, dust, lint, shards, just pieces, bits and pieces. Yeah, lint is sediment. Broken off, it's broken off, think about it. It's broken off, torn off pieces of your towel, your sweater, your jeans, your shirt. Right? Solid sediment, they're solid pieces. Wide variety of sizes. Look at some examples of physical weathering. How do we form these smaller pieces from bigger rocks and bigger chunks of minerals? Well, leading the list, abrasion. There's one. No. Actually, that one's better. I'll read two of them there. Abrasion. Okay. See what? She's going to get it for That's abrasion. Okay. If these rocks are tumbling down a hill or landslide, okay, they're hitting each other and pieces would be falling off. If they're tumbling along in a river or a stream bed, they're hitting each other and bumping into each other, knocking pieces off each other. That's abrasion. If you have sand blowing around in a desert, hitting into rocks, it's going to knock pieces off. Abrasion. We know what this is. We live it every spring. It is a huge source of physical weathering. Frost action. Water is a very unique substance. It's very special. Most substances, when they transition from a liquid to a solid, they become more dense. When water goes from liquid to solid, it becomes less dense. It expands. Water expands when it freezes. If you've ever had a can or a bottle of something in the freezer and had it split on you, like it's a hot day, you have like a hot beer in a can, or you have a hot can of Coke, you want to hurry up and cool it off, and you put it in the freezer, and you forget about it, and you're watching TV, and you hear this, what is that noise? It's your first beer can in the freezer spraying beer all over the inside of the freezer. That water expands when it freezes. So when you have water and it drips down in between the cracks and crevices and rock, temperatures drop overnight and the material freezes, that water expands and it's just like a wedge. It'll pop that crack or fracture open bigger. Well, now if you have a bigger opening, more water can get in. When that extra water freezes, it expands even more, and it'll pop that crack open even more. Eventually, it pops the whole rock to pieces. We are more familiar with this activity in the development of potholes. That water gets in under the road, freezes, expands, and pops the pavement out. That's frost action. Breaks rocks apart all over the place. Along coastlines, you have a phenomenon that's known as salt crystal growth. You get that salt spray blowing in from the ocean, and now you have salt water that gets blown into the cracks and crevices of rocks by the seashore. When the water evaporates, the salt comes back together into new crystals. It takes space to build a crystal of a mineral. You need room for that. So as those salt crystals grow, they expand. And they will pry the rock apart in pieces and crumble it into pieces. We see this happening around here as well, in the formation of potholes and then the deterioration of bridges and overpasses. Because we use salt in the wintertime to de-ice, and that salt gets into all the nooks and crannies and forms salt crystals, and it ruins everything. I'm going to put the wrong script expansion. Expansion. This produces a phenomenon known as exfoliation. X means external on the surface. Folio is layer or sheet. It means leaf. That's where we get foliage from. Don't you people know your Latin? So it's folio. So external layers, and Asian means to make. So if you're making external layers, you're shedding your external layers. You're going to exfoliate. What do? Ladies? You take off all the dead skin on top, right? Rocks do this too. And it's because of expansion. Rocks like plutons, igneous rock that formed 30 miles underground. That formed under great pressure. If that rock should be lifted by mound building and be at the surface, is it under that same pressure anymore? Oh, not by a long shot. What do you do when you're not under pressure anymore? You relax. You relax, and you put on your sweatpants and your t-shirt, and you expand all over the couch, and just sit there with a bag of chips, and yeah, this is great, man. I don't know. It's all I've got thing to do all day. The rocks are doing the same thing. They've been under that pressure for perhaps millions of years. Once they're exposed at the surface, that pressure is gone. They expand. And as they expand, they'll crack and split. And they'll crack and split, and layers will literally peel off of them like onions, like layers of an onion. That's called exfoliation. That makes it really dangerous for climbers. Crazy people that do that. Anyone here any rock climbers in here? Brave souls that did doing that? The free hand thing and the little pin in there and put a rope. No, I'm not even going to do it once. You kidding me?
I've done the fake rock climbing.
The fake rock climbing, I can do that. That's cool. But when they're up there and they're just like hanging, like this, looking for another place to put their hand, and it's like nothing. But this exfoliation is dangerous because you put that pin in there for your rope. You don't know if that pin's going to hold you, or if you're pinning that in one of those loose onion-like layers that's going to pop and fall off with your pin in it, and take the pin, the rope, and you with it to the bottom. It'd be very dangerous. This process can be very dangerous in mines, especially in quarries, where we're digging the rock out on purpose, because we're going to use that for countertop, or we're going to use that for monument stones. We're digging it out, right? And of course, once it's at the surface, it's not under pressure. It'll pop and crack and snap. If you've ever been in an old like quarry for marble or granite, it can be really creepy because you hear the rocks popping. You sit there and you'd be like, oh, what a beautiful place. I want to visit deer. the hell is that? What? It's the rocks literally relaxing, they're resting, they're expanding, and as they expand, they crack and they split. In some quarries, especially for marble, marble forms under tremendous pressure. So once it's at the surface, it can pop and snap and literally explode. And there are instances where miners and quarrymen have been killed, and their machines toppled because rocks popped or literally exploded in shards. That's all just from pressure release. Even animals, yeah.
What is that? I mean, is it it's so compressed there's no moisture gets in, and moisture does, or is it just a molecule are so compressed that they?
Yeah, the pressure's gone, it's relaxing. Yeah, that pressure's gone, and they relax. They literally relax, and that they expand. And it's, you have limited space because you may be expanding, but it's in a space this big still. So as that expands, it pops and cracks and splits. Actually, pretty cool. Until we don't.
So like you said, just when we go to relax and just put pants on, or if you relax enough, just don't put pants on at all.
Yeah, you feel like first,
Just suck your face and weight
and then until you just burst everything out, just kind of relax. But doesn't it feel like when you guys get done with finals week and you've taken on your 8 tests and your 3 presentations and your 4 term papers, you've been for 2 weeks, and don't you feel like you're just lighter, expanded, sleep? Yeah, it's if you relax. Even animals can cause abrasion, especially animals that dig and burrow. And of course, if they're digging and burrowing and clawing and breaking up cracked and fractured rock, that lets water in as well. That's going to lead to your frost action. Mold. Yeah, mold and chipmunk. Trees. Those tree roots are going to get into the cracks and crevices and rocks that they're trying to grab something to hold on to. But as the tree gets bigger and the roots get bigger, those roots as they grow will break the rock apart. You'll see that in your neighborhood. If you have an old neighborhood with a lot of mature trees, and every now and then they'll have to replace the sidewalk because the tree root got under there and the sidewalk's all heaved up and broken and everything. That's physical weathering. Any questions? We'll look at chemical weathering on Tuesday. Take the plate. Make sure you get your name on the attendance sheet. Remember on the homework 2,